All right, so now we're going to start back at the beginning of chapter 8 and start with 8.1. Okay, so our little starter question here, so let's graph that. So what is that minus 5 going to do?
Bring it down.
Shift it down 5, correct? So where is my vertex going to be?
0, 5.
Vertex is at 0, -5. Okay, so there's my vertex. Now we're going to label our points. So I'm going to, now this is a good review from last section. So I'm going to go right 1 and up 1 squared. So what is that point now? 1, -4, good. Okay, now I'm going to go right 2 and up, how many?
4.
Up 2 squared, or 4. So what is that point?
2, -1.
2, -1, good. Okay. Now I'm going to go left 1 and up 1 squared. So that becomes, stop, cancel. So that becomes -1, -4. And then we're going to go left 2 and up 2 squared. So that puts me at -2 and -1. Okay. So there are 5 key points. Okay, so now identify the x and y intercepts. Okay, well the y-intercept we're pretty good with, right? Y-intercept's -5. Okay. Now what about the x-intercepts though? How would we find those?
It's like where the line goes through.
Isn't like anything in between layers?
Okay, you're all kind of hitting around it. All right. So what is my y value when it crosses my x-axis? Right? Y is 0. So I'm going to make y 0 and solve for x. Does that make sense? So if I make y 0 then, I get 0 equals x squared minus 5. And now we add 5 and go. So we get 5 is x squared, and x is plus or minus the square root of 5. So those are our x-intercepts. And again, we know our y-intercept is -5. Okay. Okay, so let's read here. It says, we often need to solve quadratic equations that contain a perfect square. In the example above, we needed to solve the equation x squared minus 5 equals 0. Now the technique for solving an equation like this is similar to solving a radical equation. We isolate the square, then we use the inverse, in other words, the square root, because the square root undoes the square, right, to solve it, which is what we did, okay? So if we have, now, and there's more than one way to solve some of these, okay? But if you've got a perfect square, the easiest way to do it is to isolate that perfect square and then square root both sides, okay? All right, so for example 1 then, what are we going to do? We're going to add 25. So we get x squared equals 25. Oh, sorry about that. And then we square root both sides. So we get x equals plus or minus 5. Okay. Now, when we're dealing with equations, we have to use the plus or minus thing. Okay. If you're not dealing with equations, so if I just asked you what's the square root of 25, you would say 5. Okay. When you're not dealing with equations, you deal with what's called the principal root or the positive root. But when we're solving equations, we have to account for the positive and the negative of that.
Is it the positive negative because it's parabola?
Correct. Because 5 squared is 25 and -5 squared is also 25. Okay? But yes, also because it's a parabola. All right? Okay, so what about part B here? So we subtract 4. And now we square root both sides. What's the square root of -4? 2. 2i, yeah, plus or minus 2i. Okay. Part C, what do we do? Divide by 5 first. Good. So we get x squared is 13 over 5. And then we square root both sides. But we don't like that 5 in our denominator, so we're going to times top and bottom by root 5. So then we get x is plus or minus, what's 13 times 5? Somebody say 65. Good. And then on the bottom we now just have 5. So that's as far as you want to go with that one to simplify that, okay? But again, you know, I mean, technically, we could leave it as root 13/5, but we don't, again, we don't like a square root in that denominator, so we want to get rid of that. Okay. All right, part D, same thing, right? We square root both sides. Our square is isolated. So now we get x minus 1 equals plus or minus 4. Okay, now we're going to add 1 to both sides. So we get x equals, now if we make it positive 4, 4 plus 1 is 5. If we make it negative 4 plus 1 is negative 3. Okay, and there are our solutions. Now I would double, with these you're okay, but as we go with more roots and stuff, you're going to want to check your answers, because we're going to have at times what are called extraneous solutions. Okay, but we're good here on these. 5 minus 1 is 4, 4 squared is 16, negative 3 minus 1 is negative 4, negative 4 squared is also 16, so we're good. All right, so again, part E, square root both sides. So now we get 3x minus 1 equals plus or minus root 17. Okay, can't do it, whoops. Oh my goodness, hold on. Really? I just did it again. Apparently I can't draw a 7 today, a small 7. All right, now what do? What's the next step? We're solving for x.
Add 1.
Thank you. Don't complicate this, people. So now we get 3x equals 1 plus or minus root 17, and then we divide by 3. So there are your answers. Okay, that cancels. So x is 1 plus root 17 over 3 and 1 minus root 17 over 3. Okay, oftentimes, and then this is what's called the exact value. If it wants a decimal approximation, then you just crunch that into a calculator. Okay. All right, in part F, first step, minus 20. So we're just going to set this equal to negative 20. And now we square root both sides. So we get 2x plus 3 equals, okay, let's simplify the square to negative 20.
Isn't it on the square root?
20 breaks down into,
2i, 5.
good, 4 and 5, and the square root of 4 is 2. We're going to take our I out to begin with. So we get plus or minus 2i square root 5. Again, because 20 breaks down to 4 times 5, square root of 4 is 2. And now it's easy, right? Minus 3 and divide by 2. So we get x equals negative 3 plus or minus 2i root 5 all over 2. Can I cancel those two 2's? No, ma'am, sir. Because I don't have a 2 out front with that 3. If that minus 3 were like a minus 6 or a minus 4 or something like that, then I could cancel the 2. Emma?
So is the whole answer plus negative 3 plus or minus 2i?
Nope, it's just negative 3 plus 2i root 5 over 2 and negative 3 minus 2i root 5 over 2. There's two answers there.
Okay.
Okay? And that's but you know, again, we mathematicians are lazy, so we just write it together.
I was gonna say, isn't it like the same thing that you would write in the quadratic formula? Is that what this is?
This is, yeah, we're going to head towards a quadratic formula eventually. That's section 8.3, I think, or
'Cause I remember writing this
8.2.
stuff.
Yeah. Mm-hmm. Yep. Okay, so in this section, the main part of this section is talking about solving by completing the square. Okay, because we want to get a perfect square on one side, and then we can square root it, just like we did, right? Then I think it's next section we're going to talk about. Section 8.2 is a quadratic formula. Okay. All right. Now there are advantages to both ways of, or actually all three ways. We've talked about the square root method. We're going to talk about completing the square in the quadratic formula. There's certain advantages to each of the three methods. You know, you need to learn how to do all of them. Sometimes on a test it'll say solve by this, or solve by completing the square, or solve by quadratic formula or whatever, okay? And then you have to show those steps. If it just says solve the equation, you choose which one you want to do. Okay, another way to solve quadratics is by factoring, if it's factorable. Okay, most ones we're going to talk about aren't factorable, so we need to have some other tools to be able to handle those, okay? All right, so the steps for completing the square. We want to isolate the variable terms on the one side, generally the left side of the equation, and arrange them in descending order. Then we want to divide both sides of the equation by the coefficient of x squared, if that's not already 1, and in most cases it will be. Then the second coefficient, that x term, you're going to half it and square it, and then add that to both sides. And we've now got a perfect square trinomial. Then we factor the trinomial and simplify the other side, take the square root and solve for x, okay? Now, all that's probably Greek to you right now, but as we go through this, you'll see that we're going to follow our steps, okay? So, now on example 2 here, we're not solving yet, we're going to work on completing the square. We're going to work on making perfect square trinomials, okay? So we'll skip step 1 and actually step 2 right now because our leading coefficient's all 1. All right, so we're going to go to step 3 here. So we're going to take half times the coefficient of the x term. So half of 16 is 8. Now we're going to write this 8 right down here. Okay, and it's positive. All right, what's 8 squared? So we half this number and we square it. So half of 16 is 8. 8 squared is 64. Now that is a perfect square trinomial right there. And in fact, it factors into x plus 8 quantity squared. That's why we write that down. Okay. All right, let's look at part B. So half of minus 10, minus 5. Write that down. Minus 5 squared, 25. Good. Again, that's a perfect square trinomial, and it factors into x minus 5 squared. See, that's a nice thing. When you write that down, then you don't have to worry about anything else. You don't have to worry about factoring it. You've already done it. All right, now this is a plus. Half of 10? 5. Keep the sign. 5 squared? 25. So again, the only difference here is the sign. Okay. All right, part D. What's minus 3 squared? Or I mean, sorry, what's half of minus 3? Yeah, 1.5. We're going to leave it as a fraction, though, so we're going to call it 3 over 2. Okay. Now what's 3 over 2 squared? 9 over 4, right? Now, as messy as that is a perfect square trinomial. And it's x minus 3 halves squared. Okay? All right, so look at part E. So if there's no number out front, we assume it's a 1. What's half of 1? 1 half. So we go plus 1 half, and what's 1 half squared? 1 fourth. Good. And so again, x squared plus 1 fourth is a perfect square trinomial, and it's x plus 1 half squared. Okay. So far so good? All right, now what's part F here? What's half of minus 3 fourths? Minus 3 what? Minus 3/8. Good. And then 3/8 squared is? Say 9/64. So again, as ugly as that looks, x squared minus 3/4 x plus 9/64, that is a perfect square trinomial. And it is x minus 3/8 quantity squared. So if I FOIL that x minus 3/8 times x minus 3/8, I'm going to get this right here. So answer this question now, why does the last term always have a plus in front of it? Yeah, because we're squaring stuff, and every square stuff it becomes positive. Okay, so now, if you look back at your steps, all right, we want to isolate the variable terms, which we've done. So now we're ready to complete the square. So half of 6 is 3. Put plus 3 there, and 3 squared is 9. So we're going to add 9 here. Now we have to add 9 here. Okay. So, right. So x squared plus 6x plus 9 is x plus 3 squared, and that equals 16. Now, you could make the argument, well, why don't we just subtract 16 from both sides and factor it? And you could do that. But watch how slick square roots are. Okay, now I can just root both sides. So I just get x plus 3 equals plus and minus 4. Minus 3 from both sides. So we get x equals, if it's plus 4, 4 minus 3 is 1. If it's minus 4 minus 3 is negative 7.
Why'd you subtract 3? Oh, to isolate it?
Yeah, we're solving for x. Okay.
Then you'd either minus 3 or add 3?
No, I minus 3 both times, but my answer over here is plus and minus 4.
Oh.
So if it's positive 4, 4 minus 3 is 1. If it's negative 4 minus 3 is negative 7. Okay, does that make sense?
Yeah.
All right, good. All right, let's look at this example now. So f of x is x squared minus 8x minus 1. Okay. So first thing we need to do, let's get rid of that minus 1. So we're going to just add it to both sides. Yep. So we have f of x plus 1 equals x squared minus 8x. All right, now we're ready to complete the square. Half of 8 minus 8 minus 4 minus 4 squared 16. We're adding 16 to both sides. So now we get f of x plus 17. And if that f of x bothers you, just make it a y. Okay? Because that's all it is. All right, x squared minus 8x plus 16 is x
Plus 4.
minus 4 squared.
And would you root it?
Oh, I didn't even look at that. Okay, we want to actually find here where it crosses the x-axis. So, in other words, we want to do what? When it crosses the x-axis, what's my y value?
0.
0, right. So that just goes away now. So now we have
17.
Yeah, we have 17 equals x minus 4 squared. Okay. All right, so now what do? Now we square root both sides. So we get plus and minus root 17 equals x minus 4, and then we add 4. And I'm just going to rewrite it this way. So x equals 4 plus or minus root 17. And that's where your x-intercepts are, at 4 plus root 17 and 4 minus root 17.
We actually get out of here at 106.
106, okay, thank you. All right, so number 65 here. Okay, what's the first thing we need to do on this problem?
Half of 18.
Nope, not yet.
Take out 9.
Yeah, we gotta divide everything by 9. Okay, we cannot have the leading coefficient be something other than 1 in order to complete the square. And this is where completing the square can get a little messy. Okay, so we're gonna divide everything by 9. And it's got to be everything by 9. So now we get x squared plus 2x equals negative 8 over 9. Okay, half of 2? 1. 1 squared? 1. So we add 1 to both sides. Okay. Now, this is a perfect square trinomial, and it is x plus 1 squared. That's why we write that one down. Now it's negative 8/9 plus 1. Yeah, it's just 1/9, right? And now we're ready to square root both sides.
How did that become 1/9?
What's 1 minus 8 over 9? If I have a pie and I cut it into 9 slices, and I take away 8 of those slices, how many are left?
1.
There we go. That's how that became 1/9. Okay? So we square root both sides, so now we get x plus 1 equals, plus or minus, what's the square root of 1/9 now? 1. over 3. Yeah, it's 1/3, right? Square root of 1 is 1, square root of 9 is 3. So it's plus or minus 1/3. And now we subtract 1. Okay, now again, we got to be careful. If it's positive 1/3, 1/3 minus 1 is negative 2/3. If it's negative 1/3, negative 1/3 minus 1 is negative 4/3. And there are your two solutions. First step here.
Divide by 4.
Excellent. Divide by 4. So we get m squared minus 4m equals negative 3/4. All right, half of minus 4? Minus 2 squared is 4. So again, this is a perfect square trinomial, and it's x minus 2 squared. Or sorry, m minus 2, it should be. Taylor, grab that door, will you? Okay, and this equals, what's negative 3/4 plus 4? Okay, how many fourths are in 4? How many fourths are in 4? 16 fourths in 4, right? Because 16 over 4 equals 4. So if I have 4 pies and I each gonna cut them into 4 pieces, how many pieces have I got? 16. So there's 16 fourths in 4. So this gives me 16 minus 3 is 13 fourths. Yes?
It's kind of a random question, but are we not allowed to use calculators on tests anymore?
No, you'll be able to use scientific on some.
Okay.
So,
On the
I would
final,
bet-
Get one?
yes. Okay. So now again, we square root both sides. What's that?
Can you do 13? I don't think so.
Well, you can't do 13, but we can do 4. Oh, grab that door. Wait, let's see. Oh. Get out of here. Never mind. Okay, so we get m minus 2 equals plus or minus root 13. What's the square root of 4? 2. And now we add 2. So we get m equals 2 plus or minus root 13 over 2. Now generally you want to get a common denominator. So if this is 2 over 1, I'm going to times top and bottom by 2 here. So our final answer we're going to have is 4 plus or minus root 13 all over 2. And that's going to be our final answer. Okay, so example 3 here, first step. Add 3 to both sides. So I'm just going to put a 3 right there, we'll cross that out. And now what's our next step? Divide by 2. Divide everything by 2. So we get 3 over 2 equals x squared plus 5x. Okay. All right. Half of 5? 2.5. Just but leave it as 5 over 2. Just stick that number over 2. So we're going to add 5 over 2 here. Now what's 5 over 2 squared? 25 over 4. That's what we're adding to both sides. Okay, so on the left side here, we got to get a common denominator, which is 4. So times top and bottom by 2. And 3 times 2 is 6. And 6 and 25 is 31 over 4. And that equals, what's my perfect square trinomial? X plus 5 halves squared. Again, that's why we always write that 5 halves down. Because then you don't have to worry about factoring x squared plus 5x plus 25 fourths. That's just ugly. So when you take half of that middle number, write that down, because that's what it's going to factor into in our perfect square trinomial. Okay? Are we all clear on that? On that part of it? Okay, write it down so you don't have to try and factor. Okay? Did you say no?
Don't try and factor.
Right. write 5, when you take half of 5, write that number down, because that's what it's gonna factor into. Okay, when you complete the square. All right? So now we're ready to square root both sides. So we get plus and minus root 31 over 2 equals x plus 5 halves. Oh, no, we did get it. And now we minus 5 halves. So that equals negative 5 plus or minus root 31, and all of that is over 2. Done.
What's
You
that?
said equal to x?
That's a check mark.
Where do we go equals x?
No, 5 over 2. I thought it was a G.
Yeah. Yeah, that equals x, Josh, you're correct. You want to irritate me even worse? Lie to me. You can ask my kids about that one. Okay, so now we want to find the x-intercepts. So what does that mean? That means f of x is
G of x is 0.
0. In this case, yeah, g of x is 0. So we make that 0. Okay, and then now, again, what's our first step here?
Yep.
Nope,
Minus
not yet.
1.
Let's add 1 first. Okay, so we get 1 equals that mess. Okay, and now we,
Divide by 2.
now we're going to divide by 2, right. So we now divide everything by 2. So we get 1/2 equals x squared minus 3 over 2x. All right, folks, what's half of minus 3 over 2?
-3/4.
Minus 3 over 4, good. Okay, just double your denominator, and that automatically takes half of it, okay? All right, what's negative 3/4 squared?
9.
9 over 16, good. Okay, let's fix the left side. So common denominator is
9 over 16 plus half,
plus 1/2, right? So how many sixteenths are in half?
7/16.
Nope. What's half of 8 sixteenths, right? 8 sixteenths is 1/2, right?
Because 8 times 2
If
is
you're not
16.
sure, yeah, just times both sides by 8 here. Top and bottom by 8. So then we get 9 plus 8 is 17. So that's 17 over 16. And what does that equal? What does my trinomial factor into?
It's,
X minus 3/4 squared. Again, that's why we write that minus 3/4 down. Because factoring x squared minus 3 halves x plus 19/6 or 9/16, if you don't know it, that's really hard. Really, really hard. Okay. All right, now we know the drill. Square root both sides. And I'm just going to switch sides here. So we get x minus 3/4 equals plus or minus root 17. What's the square root of 16? 4. And then we add 3/4 to both sides. So that equals positive 3 plus or minus the square root of 17 all over 4.
Let's merge that window back.
Right, so that's 0, and then we're going to subtract. Okay, so again, so we make y 0. We're going to minus 14 and divide by 2. So we get negative 7 equals x squared plus 4x. And now we're ready to complete the square. So half of 4 is 2. Write it down. 2 squared is 4. So we get 4 minus 7 is negative 3. And x squared plus 4x plus 4 is x plus 2 squared. Okay. And again, we know the drill. Oh, this is why I put this one in here, because we're going to get imaginary answers. That's why we didn't have one like that before. Square root both sides. Okay, and then I'm gonna flip it over. Okay, what's the square root of negative 3? I root 3. Good. And we minus 2. So we get x equals negative 2 plus or minus I root 3. Done.
Can we just like